Okay, in this last video, I'm simply going to kind of talk through some of the notes here, and I think that these are included in your packet already. Some of these topics kind of get a little bit advanced, and we're going to see them more later, but I just wanted to kind of talk with you a little bit about multiplying vectors. Okay. The one type of multiplying vectors that we're going to use a lot now is multiplying by a scalar. So up here it talks about how to multiply a vector by a scalar. Now remember that a scalar is just a number. Guys, the effect of multiplying a vector by a scalar is to basically change the vector's length and or its direction. So for example, if I use a scalar of -1 and I multiply this vector times -1, what I do is basically just change its direction. And so the length does not change, but I flip it by 180 degrees. So whenever you have a negative multiplied by a vector, you flip the vector by 180 degrees. Now, what if you multiply by a number that's not 1? Like say I multiply by the number 2, what I do is I basically make the vector twice as long. Okay, and hopefully you can kind of see that. So basically stretching the vector is what happens when you multiply by a number that's bigger than 1. Question for you is what happens if I multiply by, say, +1/2? And what will happen is that I will basically take the original vector, it will have the same direction, but now it's going to be half of the length. So I'll just put a note here that that vector is half as long. So multiplying vectors by scalars, it's pretty easy. You're just changing the direction if there's a negative sign and the length if the number is not equal to 1. Okay. Now I'm going to talk about this fairly quickly because this gets a little bit more advanced. But it is possible to also multiply a vector by another vector. And there are two ways to do that. One way is called a dot product, and one way is called cross product. The dot product is the one that you probably are most familiar with from last year. A dot product is basically this. If you take vector A and you multiply by vector B, and you use a dot product, the way that you handle that is that you would say take the magnitude of A times the magnitude of B, and you multiply by the cosine of the angle between them. This is something we did last year when we learned about the quantity work. We said that work is equal to force times displacement. But the way that we calculated work in class was to take force times displacement times the cosine of the angle between them. So hopefully you remember that. Now, what would happen here would be, let's say that as an example, we have 10 newtons of force, the object moves 2 meters, but there's a 60-degree angle between those two things. So you could look at this picture up here, right? So maybe A is the force, but B is the direction the object is actually moving. And what happens here is that you take the 10 newtons times 2 meters and multiply by cos 60, and that makes that gives you 10 times 2 is 20, times cosine 60 is 1/2, which is 10 joules. The effect of the cosine 60 is to actually make the joules smaller, right? Because cosine of 60 is 1/2. And the reason is because these vectors are not lined up with each other. So when you take a dot product between vectors, what you're looking for is how well do the vectors line up with each other. The more they line up, the more your dot product is going to be equal to. Okay? And that should make sense to you if you think about work, because work is done when force and displacement line up with each other. In the other extreme, if the vectors don't line up at all, that would be a 90-degree angle, and in that case, no work is done. So if we had A and B like that, then A dot B would be equal to 0 because the vectors are not lined up at all. One other thing I'll say about dot products is that the answer to a dot product is always a scalar. It's always a scalar. So we talked about joules here. Joules are scalars. And so dot products will always give a scalar, and you will not have a vector. The joules do not have a direction. So that's an important thing to keep in mind. The other type of way of multiplying vectors is called a cross product. And last year we actually used cross product, but I don't know if I called it that. A cross product is written differently. You actually put an x here. And instead of multiplying times the cosine of theta, you multiply by the sine of the angle between them. So the example that we learned about last year was torque. We said torque is equal to lever arm times force, and that was our formula that we used. But when we used the formula, we actually put a sign in there. So we said if the lever arm was a half meter and the force was 100 newtons, that I would take the sine of the angle between them to find the torque. In this case, it's a little bit, this is the opposite of a dot product, because when you take the sine of the angle, you're looking for the parts of the vectors which are perpendicular to each other. So remember, you get a lot of torque when you have this situation, when you have like a pivot, and then you have a lever arm, and then your force makes a nice right angle to that lever arm. That's how we get torque. Okay? Think about opening up a door. That's what you want to do. Apply the force perpendicular to it. And so we would say that to get the most torque, you need to make that angle as close to 90 as possible. And so the sine function kind of takes that into consideration, because the sine of 90 is equal to 1. So in this case, we would say that this is a maximum torque. So we're going to see a couple of other examples of cross products in the class. Mostly cross products come with rotation. Okay, so that's why I use the example of torque, is because for the most part, to cause rotation, you need to have a perpendicular force. So we'll learn more about cross product later in the year. I just wanted you to get a preview though, and to be aware of that word. All right, so hopefully in this last lesson you've learned about multiplying vectors by scalars, and then you've learned about the idea that you can multiply a vector by another vector in two different ways. One is called a dot product, one is called a cross product, and those are different rules and they apply to kind of different situations. Okay, so then you guys can go ahead and keep on learning, and we'll see you in class soon.